science in the morning.
People always give me questions. This is why I have to be in the high school.
Right.
You guys always-
Eyes and ears, your iPads are off.
Talladega Nights.
Alright guys, so I'm gonna talk to you guys about Euler paths and circuits. So no one's ever heard of anything like that, right?
I know it's circuit, and I know
That's a good
it's
start, that's good stuff. So what I'm gonna have you guys do is you guys could, get on your iPad and open up your blank sheet. Is that's on Notability, right? Okay, I'll have you do that, please.
Nice.
So normally I'd like to do this activity with toothpicks, but for health reasons, I decided not to. Also, when I was in middle school, if I was given a toothpick, I probably would have poked my friend. So I didn't want to do that. But we're gonna have a warm-up activity. So what I'll have you guys do is you'll just draw the toothpicks instead. But what we're gonna do is we're gonna take a toothpick away one at a time until we get rid of all the toothpicks. Does that make sense? But we can only take a toothpick away if it touches the corner of another toothpick. So if I take the right toothpick away, then I could either take the top toothpick or the bottom toothpick, but I couldn't take that one. So I'll give you, I got 3 examples here on this next slide, and there's a toothpick on the left, it disappeared. But what I'll have you do is you'll draw each of the toothpicks, and then one by one you can just erase the toothpick as you take it away, and your goal is to get rid of all the toothpicks. You guys can go ahead and like work with a partner or work by yourself, kind of talk through it.
Because you just roll over everybody with the marker, that's probably why.
Now I have a blank line.
You can only pick it away. You go back.
No, because I won't make it over the
Alright guys, once you finish the first one, go ahead and try the second one, please. That one's a little bit harder.
Yeah, so then erase it one at a time.
I've already done this one. I the first one, the second one.
We're down to 1.
Yeah, and then
I
you
know
can
it's
erase
going
it.
long.
There you go. That was the first one, right? Go ahead and try the second one. Yes. So guys, it's based off of the corners. If you pay attention to the vertices, that'll help you a little bit. What's up? Okay, so pick a toothpick. If we take away the red one, alright, now, you've got to touch it like that. Alright, so, and the toothpick still have to touch it. So you just twist from this one, right? And now on the touching, which is, it'll be a triangle, we're gonna erase that one. And then that one, which is
Okay, so the top one
the touch one, right?
side one.
You can clear that one too. You clear all 4. Does that make sense? Next one.
Guys, make sure your conversations that you're having are revolving around these, because if you can't get these to work, it's gonna make things tricky, folks.
Number 3, so that top one? Alright, now which direction do you want to go next?
Start.
Yep. And touching
I figured out.
this toothpick on the touching.
Oh, is he not in?
I don't know, you gotta make.
I can call him.
That's okay, if they're not like.
Wait, so, like, are you sitting back here?
Probably not.
Alright, how we doing, guys?
I don't know. Because everybody's
Corner by
starting
corner,
with
try to get rid of all of
So we
them.
start here. What's up? And that one.
Which one are you doing?
That's the thing, you're trying to come up with a method that works.
Actually, I'm just.
The third one?
I'm trying the third one, but
Is there a time where, like, let's say I start remembering something in my
Yep.
We'll see how it goes, if it doesn't work. Keegan and Christina.
Hey guys.
we don't know oh, we can only have one part. We only have one part. We need a writer. Or Petty. Petty could be looking for you. I'll be there.
Oh, for wrestling?
No, but like, you can't sit with us. You go over there. Start, take them out.
I'm not sure what you guys think.
Okay, we got it. Look, we're in that match, bro. Come on now. So, we did outside first, then inside.
Let's say don't block his
Camera, this one's connected to this. No, you can't do that. You guys get this. We get started. Hey, Bentley. You don't have to Bentley.
But sometimes it doesn't work.
You get it. It's your bad day. Did I do it right? Alright, bro. You look like that. Turn around.
And then touch it down.
Well, now you're not.
Alright, so which one do you want to take it first? Alright, pick one. Alright, now, you can erase that one. You're ready to take that one. Yeah? Okay, which one do you want to take away next?
You have a question
I
and.
can
This one, I started this way, so you have to take one away that's touching those right
No, but
here.
then you can't.
Okay, so then if you take away that one, you can only take away the
So
ones that
if you
touch.
took away that bottom one, you stuck the bottom right there.
See, now you
You don't want to do that. So you go up. Alright?
Yeah.
I can erase that one.
Okay, so then if you erase this one, then your only choice is either this one or this one. Okay? Okay? And now you're gonna be in trouble because if you take this one away, you don't really need to go with, if you take this one away, then you leave that guy hidden.
So we're back to then just go up to the left. Yep.
You also have to.
I went to a bunch of why.
I don't know, just have like.
Good job. Alright guys, how are we doing? Alright, so who wants to walk me through what they did for the first one?
Yes.
I removed the top one,
Top one,
and then I removed the one on the side.
Yep,
That one.
that
and
one.
then I removed the last one.
and the bottom one, perfect. Who wants to explain the second one? Did someone get the second one?
I know.
Go Bentley, I got you.
Yeah,
So I'll take the one out in the middle.
out of the middle, alright.
Yeah, and then take the bottom one.
The bottom one, this one,
Yeah.
okay?
And the left side one.
Yep, or left side or right side?
I don't care.
We have to take right side, right?
Right one, yeah.
Yep, and then where'd you go next?
The other side?
The other side?
No, the
That one is,
top
yeah,
one. Top
there you
one.
go, top one,
And the other side.
other
Use
side,
your
perfect.
directions.
And then who wants to explain the last one?
No.
Did someone get the last one?
I did, but I don't know how to. I have a question.
So, I have my dry erase markers up there, if one of you wants to trace over it, and then show you this how you take it away one by one, just don't erase my Ricky Bobby
Tell
stuff.
it. Come on, tell it. Let's go.
Slingshot engaged.
Hey, who
You
wants
want
it
it?
down?
There you
Who
go.
got
Oh,
it?
bro, yes.
So if you wanna trace it first, Brooke, that might be the easiest thing.
You can't erase the computer.
This is pretty hard, right? It made you guys think. Yeah, it makes me think too.
Oh, maybe they are.
Perfect, good job. So if you didn't see what she did, she went here, up here, cleared, did you clear top one?
Yes.
Cleared this one, cleared this one. Does that make sense? So you guys see how I made a path, right? You guys, I hope you guys can see a little bit where I'm going. So, just a little bit of background here. There's a Swiss mathematician and physicist, and his name's Leonard Euler. Everyone say Leonard Euler. So, he's just a really smart guy. That's what physicists mean and mathematicians. But he lived a long time ago. You've probably heard a little bit about him. If you guys look on your calculator, there's that E button. And if you push it, it's like 2.7 and then a whole bunch of decimals. But that number is actually named after him. But what we're going to talk about today is Euler paths and Euler circuits. So that warm-up example, those were actually you guys working with Euler paths and Euler circuits. So at the table, I want you guys to talk about what a path is, just in general, and how it relates maybe to math, and then what a circuit is, and how it might relate to math. Oh, path. So like you're talking
The things that you like create, like the way you don't like, there could be a path for fire. Well, I'm trying to figure this out. I'm trying to think of
The circuit is like the thing that's like
This is actually good for helping.
what's a circuit?
Alright guys, what's some of the things you guys said when you were talking about what's a path?
Can you follow something? Something follow.
Something follows, yeah? So like if you're like walking out in nature and there's a dirt road, is that a path?
Yeah.
And how do you know it's a path?
There's like not a grass.
Yeah.
It's like
So you know it's a path because it's like, it's going somewhere, right?
Yeah.
And then normally, is it just a straight line or do you have like different options you can take?
Different
Different
options.
options, right? And then what did you guys say for a circuit? What do you guys know about circuits? Or what were you thinking about? Like
A circle, electricity.
Circle, that's
Circle
what I
with
was
the-
thinking.
yeah, me too.
Electricity, that's good.
Circle with the line.
Like a mothership, like all the computer parts and boards and stuff.
Yeah.
What about racing? Anyone, any car fans?
Kobe.
Alright, what do you know about like racing circuits?
They're in the circle.
It's in there.
Like basically
There's a bunch of definitions for that.
Right, but I think some of you guys were hitting on it, that circle bit, right?
Talking about like Daytona or like?
Oh, Daytona 500.
Yeah. Think of a circuit, you got all sorts of different directions, but it loops, right? There's a loop, there's some sort of circle in it. So, looking at Euler paths and Euler circuits, I'm gonna kind of look at the applications first. That way you guys kind of understand, like, there's a reason we're studying this. And then I'll explain how they work, how we solve them, and then how it connects back to that warm-up that we did at the beginning. So it applies to like delivery and selling. So Euler paths and circuits are all about maximizing and finding the shortest route. And so it doesn't make sense to go like all the way to the far side of town and then go to the other side and then back to the first side, right? You want to take the shortest route possible. So they use it in in delivery. We use it in football. How many football fans? Man, I thought you guys would have higher hands, especially my guys. But there we go. So when the quarterback receives the ball, right? He doesn't have a lot of time to look at all the options. So he wants to find the shortest route. Also with road work, people don't like spending too much time in the car, more than they have to, and then traveling because we're all excited about vacation. So if you're thinking of like a mailman, he'll be driving around, and he's not gonna deliver one side of town and then the other. He wants to deliver the fastest way possible. So actually my dad's a mailman, that's Mr. Bentley, the other Mr. Bentley. And a lot of times they take different paths, that way they can deliver the fastest way, that way they're not working until really late into the night. And then I was talking just a little bit earlier, but a quarterback receives the ball and he has to look at all the different wide receivers, right? He doesn't have a lot of time because the defense is coming. So he needs to find the fastest way to look at all the possible receivers without getting tackled. So he has to-
Offensive line?
yeah, or you could have just a really good offensive line, but sometimes the other team has a really good defense. So depending on the routes that the receivers run, the quarterback's going to be looking at different players based on this. And it's all about finding a short path to connect to different players. And then this is a whole bunch of really big words and it might be a little confusing. But this is to show an example of who's been on a plane before? Yeah, me too. Yeah. So sometimes if you fly, you might have like a connecting flight. Sometimes you fly from one spot to another spot because it's cheaper. Where have you guys flown out of? Have you flown out of like Denver or Pennsylvania? Yeah.
Houston.
Did you guys fly out of Houston?
No, Kearney.
Right. So yeah, you probably drove to Kearney and then flew. So depending on where you fly out of, there's like cheaper routes and there's also faster routes. So we're gonna look at how those definitions of paths and circuits that we talked about earlier connects to the math and those applications. So if you so a path we can define as touching all the vertices, and then it doesn't have to use all the edges, but it can. So like with, let's see, we'll use that first example from the warm-up, or the second example, right? So I have vertice. So if I just take a box, can everyone see? And go all the way around, I made a path, right? But I didn't use all the edges. And then an Euler path is one where it's all the paths and it doesn't return to the same start point. So, and I'll show you some examples here. But if you notice with that second example, there is one correct way that you can solve that equation. And then an Euler circuit is where it starts one spot and then finishes in the same spot. And it uses every edge. So when we're dealing with Euler paths and circuits, we count the edges. So if you're thinking of going to like a store and there's only 2 roads, you can like only take some roads to get to certain spots, right? So when we count the different edges connecting to each vertice, we're finding the shortest way that we can find those paths. So I'm going to show you an example here, right here. So if I wanted to get from church to the store, how could I take that path? You just go straight, right? There's only one way you can get there. What if I wanted to go from Grandma's house to my house?
Go to
Whoa, one at a time. I need to see hands, please, sorry. Yeah.
You could have gone to the Pizza Hut, then to your house.
And then is there another way we can do it?
To the store, to the school.
Alright, Aiden said, yeah, store, school, to my house.
School, store, and
Yeah, I could go Grandma's house to store, to school, to Pizza Hut, to home, right? So there's a whole bunch of different options. What if I wanted to go from school to church?
You can
Go to the store.
Oh, hands, please. Alright, broke it.
You can go to school, to store, to the church.
There you go.
And then that's.
Is there another different one?
You could go to Pizza Hut and then your grandma's house and the store and church.
What if I wanted to go from church to home? Yeah, Rebecca?
You could go from church to home.
Yep.
And you go from church to school to home.
Yep. And since I'm really tired, I'd probably take that fast route. But maybe if I wanted to relax because Mom had cleaning for me, when I got home, I might go to church, store, Grandma's house, Pizza Hut, swing by the school, and then go home. So there's different paths, right? But if you see that line connecting from church to store, the only way you can get anywhere to the church is by going by the store, right? So when we're counting these edges, it's because there's only so many different paths that can connect it. So we see a little bit of that real life example. So a path, we said earlier, is it connects all the vertices. So an example of that would be that first example. Now, second example, you see how you just have F kind of floating? There's no way you can get to F. Maybe you like take a plane or something like that, but even then, you don't have an option to get there. And then an Euler path, we see by counting the vertices. I'm going to go back real quick. So how many edges do we have for A? We got 1, 2, 3, right? How many do we have for C? 2. How many for B? 2, 3. There we go. And then D? 4, and E?
2.
All right. How many do we have for F? 0. So we know it's not a path if we have a vertice that doesn't have any edges. But then with a Euler path, we have to have, we can only have 2 vertices with odd edges. So how many do we have for number 0? We'll start with 0. 3. How about for 1?
2.
2. How about for 2?
2.
How about for 3?
2.
And how about for 4?
1.
How many odds do we have?
2.
2. Is that the number we needed?
Yeah.
Yep. So when we have a Euler path, those odd edges, that way we use the odd number of sides, we have to start there. So if I start on 0, what's a way that I could clear all those toothpicks again? Anyone have a guess? 0 to 2 to 1. And then 3 to 4. There we go. And we just cleared all those toothpicks. What if I started on 4?
3, 4, 1, 2.
There we go. Now it's just the backwards of what we just did. So on this side, I'll flip over. How many do we have for 1? Wrong side for 0. Start with 0. 3. And how about for 1?
3.
How about for 2?
3.
How about for 3?
3.
And how about for 4? So we count the number of edges. There's 1. There's 1, 2, 3. 1, 2, 3. So how many odd edges do we have? 1, 2, 3, 4. Can we make an Euler path out of this? No, right, because we have more than 2. What if we have only 1 odd edge? What does that mean? Is it possible to have an odd number of or an odd edge without a vertice? So I'm sorry, so we have 2 vertices, right? Can I have just 1 vertice or 3 with an odd number?
I just have a question.
Yeah.
How do you know how many paths without like having to like actually?
So when we count if it's got an Euler path, it has 2 vertices, right? Because we counted right here. So when we have the odd vertices, we start there or end there. And I was just about to show you right here. So those odd vertices are where you'll start or end. And then for my next one, we'll see what an Euler circuit looks like, because you can actually start a couple different spots. Does that make sense? Yeah. Okay, is there any other questions? I know this is like probably making you think really hard, huh? It makes me think pretty hard. Do we have questions? Alright. So an Euler circuit is where all the vertices have an even number of edges. So how many do we have for letter A? How many edges are touching? 2. How many do we have for B? 2. How about for C? 4. How about for D? For D? F? G? H? How many odd numbers did we say? 4. We didn't say any odds. We didn't have any odd edges, right? And then for this next example, just kidding. We're going to start. If I start on A, what's a path I could take? Go to C. Where do you want to go next? D.
F, E.
G. And then we can just complete, right?
Yeah.
There we go. What if we start on B? Okay, if I go C, A, I'm stuck.
C, E. C, E.
So if I go C, where would I go next?
C, E.
D,
F, A, D, up to E,
go.
Oh, yeah.
I could also go B up to C to D, down to F, up to G, and then down to E, over to A, and back to B. So there's a whole bunch of different options, right? So with an Euler circuit, you could start on A, or B, or C, or D, or E, or F. You can start anywhere. So when I had you guys take those toothpicks, some of those paths you had to take that middle one in the box with the diagonal. But with Euler circuits, you can start anywhere. So we're gonna we have to have an even number of edges though. That's important to remember. So how many do we have, looking on the second equation, or for the second picture, how many, edges are touching A? Can we have an Euler circuit out of it?
Yeah.
No.
No. But we can continue, we'll look and see, how many do we have touching